So the thing that actually converts electricity into light is the emitter itself. So there are a number of scientific challenges that are still out there in OLEDs, particularly in emitters. Even though you can go to the cell phone store and buy yourself a cell phone that's powered by OLED emitters, and active matrix OLEDs are present in cell phones and in televisions, and it leads people to think that all of the issues are solved. There's a lot of questions of the thermodynamics of OLED emitters. What is it that leads to their degradation? There are a lot of questions about the solubility, that this is a mixed system. So how do we keep the OLED emitters dispersed? What controls their solubility and the phases that they're in? We spend a lot of time working through different structures for OLED emitters, where we change the ligands that are bound to the central metal, we change the groups that are on the periphery, and it changes the physical behavior of that emitter significantly. And so we spend a lot of time iterating through different structures and then asking ourselves, how did that change affect the properties of the emitter? How did it affect the properties of the OLED? The lifetime of red OLEDs is very, very long. The lifetime of green OLEDs is very, very long. Very, very long, I mean decades. And in fact, the extrapolated lifetimes for red OLEDs can be as long as 100 years. The lifetime for blue OLEDs is much shorter. And it largely comes from processes that we only sort of understand. The real goal here is to minimize that degradation of the emitter and the matrix while the device is running, so that the blue OLED, just like the green and the red OLED, will have a lifetime of decades. You're going to have a solid-state lighting panel, which is what the DOE is most interested in right now, that will be installed in the house, and it's going to live as long as the house lives. Somebody's going to take it down because they don't like how it looks, not because the bulb burned out.